doing? So log base 10, which is just your regular log button on your calculator, right? Of 4,000 is 3.602. Is that correct? Again, that one you just punch in the log 4,000. You should close the parentheses, but you don't necessarily have to. 3.602. Log base 10 of 5,000 is 3.699. Correct? Do you guys remember how I know those off the top of my head? Yeah, 1,000 is 3, right? Log of 1,000 is 3. And every time you double it, it goes up by 0.301. So to get from 1,000 to 4, you double it once, it's 2,000. Double it again, it's 4,000. So it's 3 plus 0.301 twice is 3.602. This one, I go off of 10,000, which log of 10,000 is 4, and I cut it in half. So I subtract the 0.301. Log base 5 of 625 is 4. 5 to the power of 4 is 625. Now, if you didn't see that, how would we do the change of base calculation? Well, it's log or ln, either one. It's the number where the object of the log, which is the 625, over the base of the log, the 5. So I could do log of 625, close the parentheses, divided by log of 5, gives me 4. Or I could use ln of 625, divided by ln of 5. Also gives me 4. Doesn't matter which. Now, before I move on, can anybody give me a guess at what log base 5 of 1,350 is going to be? Most people would guess the 4.301, but it's not. We doubled it, but this is not log base 10. So the doubling is not 0.301 anymore. If it's base 5, it doubles at 0.478. So just remember that doubling being 0.301 only applies to a log base 10. Number 4, log base 3 of 729 is 6. Very good. 3 to the power of 6 is 729. Again, log of 729 divided by log of 3 will give you that result. Now, this one, number 5, we have to use that change of base formula because 4 is not evenly go into 37. So it's log of what over log of what? 37, and it goes on top and 4 on bottom. So log 37 divided by log of 4, we get 2.605. How are we doing so far? Good? Well, now this next one, ln of 20, I'm just going to punch in ln 20, 2.996. Any questions on those? What do we use those for? Well, remember they are an inverse of an exponential. If I have 10 to the power of x equals 800, how do I solve that? I have to get rid of the 10, don't I? I have to get the x by itself. And remember, we have, like 3x equals 12. How did we get rid of the 3? We divided. 3 is multiplying x, so we divided. X equals 4. Or we might have x plus 7 equals 9. How did we get rid of the 7? We subtracted. 7's being added, so we subtract it to get x equals 2. We even had x to the third power equals 125. How did we get rid of the third power? Third root. That gives us x equals 5. Over here, the opposite of having a base with x as the exponent, the power of the exponent, is to do a log with a base that's equivalent to this base. It's a log base 10. So the log base 10 and the 10 to the power of cancel out, leaving us with just x. Log base 10 of 800 is 2.903. Perfect. So what would I do on something like this to solve it? Yeah, we have to isolate the exponential here. So we got to get rid of the 30. Subtract 30. So we've got 10 to the x equals 250. Now what would we do? Yeah, log base 10, of course, to get rid of the 10. So the log base 10 and the 10 to the power of cancel out. Log of 250, 2.398. Very good. We might even have something like this. Oh, let's see here. What should I, oops, that's wrong. I want to go 748 is what I wanted there. So this equation has some layers to it, but again, we're going to isolate the exponential. So how do we get that by itself? Well, it's been multiplied by 7 and then had 8 subtracted from it. So when we take it apart, we go backwards or take off the last piece first, which is the subtracting 8. How do we get rid of that? What do you think, Jeremy? What's the opposite of subtracting 8? Adding 8. Very good. So we add 8. That gives us 7 times 10 to the x equals, adding 8 there is 756. Now we still have to get rid of that 7. How's the 7 attached to that 10 to the x, Jordan? So how do we get rid of it? Divide by 7. Very good. So we've got 10 to the x equals 108. Then what? Now we do the log to get rid of that 10 to the power of. So x equals the log of 108 is 2.033. So 2.033 x equals. We can even continue to layer it. Looking at something like this, 5 times 10 to the power of 3x plus 2 and minus 9 equals 796. Well, again, we're going to isolate the exponential. Even though there's a bunch of ugly crap in that power, we don't care. We're going to isolate the exponential. It has been multiplied by 5, and then 9 has been subtracted. So what's the first piece we take off? Jeremy? The last thing that was done was subtracting the 9s. How do we get rid of that? Add 9. Very good. So we've got 5 times 10 to the 3x plus 2 equals, over here that's 805. What's the next thing we have to get rid of? The 5. How do we get rid of it? Divide by 5. Very good. So 10 to the 3x plus 2 equals 161. And then? Well, now we've got the exponential by itself. The next thing we got to get rid of is this 10 here. How do we get rid of it? It's the base of an exponent. We get rid of it by doing a log with the same base. Log base 10. So log base 10 of the 161 2.207. Okay. But notice on the left side, we're not done yet, because all we did was we got rid of the base of the exponent. We're left with what was in the power, the 3x plus 2. So now we still have an equation to solve. 3x plus 2 equals 2.207. So to solve that, we will start by subtracting 2. 3x equals 0.207. And then we divide by 3. Very good. X equals 0.069. Correct? What do you think? Not so bad? Well then. Tell me what to do here. We've got to subtract the 5. So we're left with 8 times 3 to the power of 2x minus 7 equals 216. Divide by 8. Very good. So 3 to the power of 2x minus 7 equals 208. And then there you go. Log base 3. It has to be a base 3 because the base of this exponent is 3. We're getting rid of the base. So log base 3. So that cancels out that, leaving us 2x minus 7. Log base 3 of 208. $2.639. Does that look correct? Something's off there. Oh, I forgot to do my parentheses, that's why. Log of 208, close parentheses, divided by log of 3. 4858. There you go. 4.858. Then what? Yeah, now we just solve it like a regular equation. We add 7. 2x equals 11.858. And then divide by 2. X equals 5.929. Pretty slick stuff, huh? Maybe try this one on your own. Give that one a shot in your notes. We'll go over it. So where'd you start? On the paper? That's probably a good start, yes. What'd you do first? We add the 12. What do you get? Yeah, so 4 times 2 to the 5x minus 3 equals 512. And then divide by 4. 2 to the 5x minus 3 equals 128. And then log base 2 gives us 5x minus 3 equals 7. And then add 3. 5x equals 10. And then we divide by 5. X equals 2. Good deal. How many you got that? Would have got there if I gave you a little more time? No? You had it? Okay. It's okay. It happens. Try this one. So what do we do first? Subtract 9. So 7 times e to the 2x minus 1 equals 64. Then divide by 7. So e to the 2x minus 1 equals 9.142857 approximately. And then what do we do? Log base e, otherwise known as ln. 2x minus 1 equals, we got to do the ln of 9.142857. 2.213. And then add 1. 2x equals 3.213. And then divide by 2. X equals 1.607 approximately. What do you think? Loads of fun? Blazes of glory? Try that one. So let's take a look at it. We'll let Jordan off the hook here. There we go. So the first thing we have to do is divide by 12, which of course gives us e to the negative x over 8 is equal to 13. And then we do the ln, which is what? 2.565. So negative x over 8. Now I can write it like that. Now I can actually do this in one step if I want to. When I have a fraction, remember if I have negative 3/4, I can treat it as negative 3 over 4. I can treat it as negative 3 over 4 or 3 over negative 4, correct? I'm going to change this and I'm going to treat it instead of a negative x over 8, I'm going to treat it as x over negative 8. So now how do I solve it? Times negative 8. Very good. So I get a negative 20.52. You could have multiplied by 8 and then divided by negative 1. Would have given you the same result. Is that what you did? Yeah. I'm just saving myself a little work because, well, I'm inherently lazy. Try that. Yeah, that's a parentheses before the x. This here is division. Okay, so this is one that actually has some things we can do before we start to solve. What's the 120 divided by 8? You could also multiply it by 8 over 120. But I mean, this one divides out even, just we'll do it as 15. What is 200 times 0.3? 60. That makes life a little easier for us. Now, there are going to be times where they're not so easy to combine. And we'll look at that example next. But now to solve this, my next step would be to divide by 15. So I've got e to the negative x over 60 equals 11.5 divided by 15. So 0.767. And then, of course, we're going to do the ln of that. Now, remember while we talked about keeping it in the calculator, I've got that 0.766666. I'm going to do ln second answer so that I'm not typing that back in and getting a round off error in it. So that is negative 0.2657. So negative x divided by 60 equals negative 0.2657. Guess what? I can just multiply by negative 1 or divide by negative 1 to get rid of the negatives. X over 60 equals 0.2657. And then multiply by 60. We get 15.942. What do you think? Good stuff? If I give you a formula like this, it says the current through a capacitor is equal to voltage divided by resistance times E to the power of negative T divided by RC. For V equals 12 volts, R equals 100 ohms, C equals 5.0 microfarad. Find T when IC equals 5 milliamps. So what's going to go in for IC here? Where did the 0.005 come from? Milliamps. Have to make it into regular amps. What goes in for V? 12. R. 100 times E to the negative. We're looking for T. Then, of course, RC. I'm going to have to put that in parentheses, even though there's no parentheses here. R times C is in the bottom of the fraction, so I'm going to put it in parentheses here. So it's 100 times 5 zeros, right? Because remember, micros times 10 to the negative 6. So I'm going to start out here. Instead of doing 12 divided by 100, I'm just going to multiply by 100. So I got 0.5 equals 12 times e to the, I'm going to put a circle there because we're a little short on time. We know what that is, right? That thing right there. Then I'll divide by 12. So I'm going to punch this in the calculator. Remember, I'm going to leave it there. 0.5 divided by 12 is 0.0416666666. Equals e to that power of negative t over parentheses. What was it? 100 times that, right? Then what do we do? Gotta get rid of the n, the e, right? So ln. So ln second answer. Negative 3.178 equals negative t over that. Now this is one, since that was 100, we probably could have just combined this to get that if we wanted to. But either way, I'm going to multiply out the negatives, multiply by negative 1 to get rid of the negatives. Now multiply by the 0.0005. So you get through that. 0.00159. 0.0016 equals t. In other words, 1.6 milliseconds is our time. You guys okay with switching between regular seconds and milliseconds? Just move the decimal 3 spots. Okay. This should be in that packet I gave you last week. Page 481, 1 through 27, the odds. Now you guys are gone Tuesday, Wednesday. So I won't see you till Thursday. Oh, trust me, it might take you the 3 days to do these 13 problems. I'm gonna have to remember that tomorrow. I'm done at 11:30 tomorrow then.